Hello, in this video, we're going to be talking about vectors. So vectors are basically mathematical objects, we could say, that have magnitude and direction. So what this means is that they have a scale or a something that shows how large they are, aka the magnitude, and a direction which shows which way they're facing. So here are a few examples of vectors. So we denote vectors by letters. So this vector here, this arrow, is denoted by A. And we tend to underline our vectors or put them in bold. But since we can't put bold letters on paper when we're handwriting, we tend to underline them. Now, because it has a magnitude, we can write 2A, which is just basically a bigger arrow, and 2 times as big as A, to be specific. And because it has a direction, if we had A going in the opposite direction, it would be minus A because it's going in a negative direction. And this also shows that direction matters because if these two are the same size, they're pointing in different directions. So B and C are not the same vectors. Okay, so we can do a few things with vectors. So we can add vectors together. So when we add two vectors together, it's almost as if we're going along one vector first and then going along the second vector. So we're just adding A and then to B. So the resultant vector, we call it, will be this line here, which will go from A to B. So this will be A plus B, like so. Now for A minus B, what we need to realize is that this is a negative here. So we need to figure out what negative B is. Well, we already know that the negative of a vector just goes in the opposite direction. This is negative B. So A minus B will go along this line. So it'll go along A and then negative B. So if I move this here, our resultant vector will be this vector here going from point A begins to where minus B ends. And we denote this as A minus B, like so. Okay. So how about scaling vectors? Well, scaling is just another word for multiplying. But because we're not multiplying two different vectors together, you won't be asked to do that. Instead, you'll be asked to scale vectors. So we multiply it by a constant. So if we wanted to find 3A, it would just be the same as having A plus A plus A, like that, because 3A is just A plus A plus A. So 3A would actually be that. So it'd be 3 times the size of A. Okay, so we can also represent these vectors in something known as column vectors. And that's if we know the lengths of the x component of a vector and the y component. So the x component is the horizontal component of any vector. Let's say this is 3. And then the y component is 2, let's say. This is just an example. So we've got our 3 and 2, like that. And for B, in fact, I'm going to make this a little bit more interesting. We're going to put the arrow like this. So let's say this length here in the x component is 1, and this length here is 3. Or in fact, a better way to write this would just be you're going 1 to the right and you're going 3 down, or we could write that as -3 if we wanted to, but we can just write it as 3. So that's another way you can put it. But basically, we can now write A as this column vector. So we put them in brackets like this, and in the top bit we put how far it's traveled in the x direction, like the x component. So that would be 3. And then we put how, yeah, it's a lot better to just do that. And then in the bottom, we put the vertical component. So it went up by 2. And for B, it went right by 1, but it went down by 3. So it's -3, like that. So those would be your column vectors. You can also find the length or magnitude. So in this case, the length equals the magnitude. You can find the length or magnitude of a vector by using something we've already learned. And that's the Pythagoras theorem. So for Pythagoras' theorem states that if you've got a right-angled triangle, you can find the hypotenuse by squaring both these terms and then square rooting. So the magnitude of A, sometimes we write it like that, is just 3 squared plus 2 squared. So that would be 4 plus 9, so it would be root 13. So that would be the magnitude of A, and then the magnitude of B would be, remember we're talking about a length here, so it's going to be positive 1 squared plus 3 squared. And that's root 10 squared. So you can see that we can find the lengths of these vectors, but remember you need to know how far along these components are. So this only really works when you have it in a graphical representation or you're told, you're given units. So how do we actually perform operations on these column vectors though? So if we wanted to add A plus B, we'd have this column vector plus this column vector. Well, all you actually do is you add the top term in each together and the bottom term in each together. So this will be 3 plus 1, which is 4. And this will be 2 minus 3, because plus and minus makes a minus, which will be -1. And that will be your column vector. Now, for subtracting, it's the same process. So you just subtract the top terms and subtract the bottom terms. So the top will be 2. And remember, now we have a double negative, so that will make a positive. So we'll get 5. Like so. And a good check can always be to kind of think about how it would look on a graph or on a drawing. So if we added these two together, it'd go up like this. And then if we went down by B, we'd probably end up somewhere around here. So we'll have about 4, we'll go about 4 across and 1 down. So it looks about right. And similarly, if we subtract B, we go in the opposite direction like this. So we'll go up by a lot and we'll go right by a little bit. So 2 to 5 makes sense. And then finally, scaling is just, for example, 3A will be 3, 3, 2. And then we just multiply each term by 3, like you would, for example, if you were multiplying a ratio, you multiply both sides, you multiply both elements. So that will give you 9 at the top and 6 at the bottom. So that's the scale, that's 3A. Okay, so we also have vector notation. Now, vector notation looks a bit like this. So for example, we can write, if we have a point A somewhere and a point B, this notation here, AB with an arrow above it, says is equal to the vectors going from A to B. Now, it doesn't matter whatever path it takes. So let's say we had this path here. So it goes down by A and then across by B. Say we have this path here. Let's say it goes down here, across here, like that. And let's call this C, D, E, F, G. And let's say we have one more path, just goes from A to B. Let's call this H. Now, the thing is, AB will be equal to any of these paths. So it will be equal to H, it'll be equal to A plus B, it'll be equal to C plus D plus E plus F plus G. When you use this notation, it's only concerned with the starting point and the end point. It doesn't matter how you get there. So long as if you pick a path, a correct path that gets you from your start to your destination, you're okay, and it'll work. So all of the different colored paths will take you to the same place. Or will be A, B with an arrow above it. Okay, so let's figure out these values. So X, Y, Y, Z, ZX, YX, and XZ. So we know, first off, that XY is A, because if our start point is X and our end point is Y here, you just have to use vector A to get from X to Y. So we can write, in fact, let me do that in a different color. XY is equal to A. And similarly, YZ will be equal to B. And ZX will be equal to C. Now, YX is, now we're going in the opposite direction to the vector. So instead of XY is positive A, but because we're going in the direction opposite, we're going from Y to X in this direction, it's going to be the negative of the vector. And similarly, for XZ, it's going to be minus C. What we can do is, let's say, write C in terms of A and B. Okay, so now what we can do is, if we get XZ, we know that that's negative C. But remember, it doesn't matter what path we take from X to Z. So we have this path here, which is along negative C, but we can also take this other path, so that's A plus B to get to Z. So we know that XZ is also equal to A plus B. So what we can write is that A plus B is equal to minus C, because if they both equal XZ. And if we want C, not minus C, all we have to do is times both sides by -1, scale them, we get that, or you can even write it like minus A minus B. Doesn't really matter. But yeah, okay, let's do some examples. In fact, I will save those for the next video.